Hi, this is Fazana here. Welcome to another video from the Fazmaths channel. In this video, we'll be working through questions involving simultaneous equations. One of these expressions will be a quadratic one and the other a linear one. We're thus finding the coordinates of the point of intersection of the parabola and the straight line, so we have two unknowns, the x and the y coordinates. This can be solved algebraically or graphically. Let's try solving it algebraically first. Okay, so you've got y equals x squared and y equals 2x minus 1. So you can tell that's the parabola and that's the straight line. So if we were just going to sketch it, so y equals x squared would look like that, and y equals 2x minus 1 would look like that, and so much for my straight lines. So you can tell that if they intersected there, then you've got an x coordinate and a y coordinate, and the y coordinate will be the same on the straight line as on the curve. So that's the way to eliminate the y. So you go y equals x squared, y equals 2x minus 1. So if y is that and y is that, then you can eliminate the y, and you've got x squared equals 2x minus 1. Now with most quadratic equations, we make one side 0, and because the x squared is on that side, we will do the opposite here so that we can take it to the other side. So we minus 2x and plus 1. So you've got x squared minus 2x plus 1. Try writing it on a straight line. Okay, it's just 1x squared. So if you've seen my video on factorizing quadratics with just 1x squared, you know that we're looking for two numbers that add to give minus 2 and multiply to give positive 1. You know they're both going to be negative, and then you've got 1 and 1. So they add to give minus 2 and multiply to give positive 1. So you've got x minus 1, x minus 1. And make it 0. And one of these expressions has to be 0. So in this case, there's just one point of intersection, x equals 1. And then remember, with simultaneous equations, you have to solve your y. So we'll go stick it in there. So 2 times 1 is 2, minus 1 is 1. So your point of intersection is 1, 1. If we solve this graphically, we would plot the two equations and find the point of intersection, which I have done. And you can tell that the point of intersection is 1, 1. Okay, let's try another example. Okay, so you've got y equals x squared minus 2x minus 5, and y equals x plus 5. So if y is that and y is that, I can eliminate the y, and I've got x squared minus 2x minus 5 equals x plus 5. Okay, because my x squared is on that side, I will make this side 0, so I will minus x and minus 5. So I've got x squared minus 2x minus x is minus 3x, and then minus 5 is minus 10. Okay, factorizing it, I've got two numbers that add to give minus 3, multiply to give minus 10. So one's a positive and one's a negative, and then I've got minus 5 plus 2. So I've got x plus 2, x minus 5. Make it 0. So x will be minus 2, or x equals 5. Okay, so when x equals minus 2, y equals minus 2 plus 5, which is 3. So one of the points is minus 2, 3. And when x equals 5, y equals 5 plus 5, which is 10. So the other point of intersection will be 5, 10. As easy as that. Just in case they give you this question, but they've written it as y minus x equals 5, then just make sure you rearrange it so that y is the subject. So you'd be taking your x to the other side, so then you'll get y equals x plus 5. So that's the only sort of difficult bit. Okay, let's take another example. And now, because it's so easy, I want to give you a slightly harder one, which is again playing around with fractions. If you can handle this particular one, the exam question you get will be a breeze. Remember, you've got to be really good with fractions and negative numbers with any topic in maths. So no matter how good you are with simultaneous equations, if you can't play around with fractions and know how to handle negative numbers, then after a while your workings will just flop. So please practice really well. Okay, so y is that and y is that, so we can eliminate the y's, and you've got 12x squared minus 5 equals 7 minus 7x. Because your x squared is on that side, we'll minus 7 and add 7x. So we've got 12x squared plus 7x minus 12 equals 0. So I hope you've watched my video on factorizing with more than 1x squared. So this time we're going to use the AC method. So that's your A, that's your B, and that's your C. And we're going A times C, which is minus 144. Remember to always pick the sign up. So you're looking for two numbers that add to give 7, multiply to give minus 144, so you know one's a positive, one's a negative. Factors of 144 that have a difference of 7, and after a while you'll find that you've seen these numbers before, so it'll just flow. Okay, and then we rewrite, split, factorize. So let's rewrite the 7x as plus 16x minus 9x and then minus the 12, and then split and factorize. So you've got 4x, and then you've got 3x plus 4 minus, those two have 3 in common, and then 3x plus 4, and voila, those two agree. So you can put it back, or you can put it as double brackets. 4 equals 0. And I took this particular example because I wanted to show you how to play around with fractions. For that to be 0, you've got 4x minus 3 equals 0. You add your 3 and you get 4x equals 3, and then divide by 4 and x equals 3/4. Okay, so x equals 3/4, and for that one you've got 3x plus 4 equals 0 minus the 4, and you've got 3x equals minus 4 over 3, which is minus 1 1/3. You're okay so far? I hope so. This is just dealing with fractions in a really fast way, so it doesn't actually muck up your flow. Okay, so when x is 3/4, let's find out what y is. So y is 7, and then I put the minus, and then I'm going to go 7 times 3/4. Let's look for some space. 7 times 3/4. Just make it look like a fraction, so then you know you're just multiplying it straight across. So you've got 21/4, which is 5 1/4. So you've got 7 minus 5 1/4, which is 1 3/4. And here, when x equals minus 1 1/3, you've got 7. And because you've got minus and minus, that'll become a positive. So always do your signs first. And to play with it, we'll make it 4/3 again. So you're going 7 times 4/3 and expand it, and you've got 28/3, which is 3 into 28 is 9 1/3. So you've got 7 plus 9 1/3, so you've got 16 1/3. So you can see your points of intersection are 3/4 and 1 3/4, or minus 1 1/3 and 16 1/3. I keep saying or, but of course it is and. It's just I love that word, or. Okay, that was all right, wasn't it? Yeah. Okay. Let's take another example, which just looks a little different because we've got a minus x squared. But again, that doesn't scare us. So don't ever let a negative number or a letter scare you. Because now, or once you've watched all my videos, no letter, no negative number, no fraction will scare you. So we've got minus x squared minus x plus 2 equals 2x plus 2. But this time, because your x squared is a minus, we're taking all that to that side, so the x squared becomes positive. So we'll make this side 0, and we'll plus x squared, or plus x, and we'll minus 2. So you've got x squared, and then you've got 2x plus x is 3 plus 3x, and then you're going 2 minus 2, which is 0. So you've got that, and it doesn't look like your normal ax squared plus bx plus c. So the only thing you can do is factorize it the easy way, and that's really easy, and that becomes 0. So you can tell either that will be 0 or that will be 0. So let's just write it the other way. So x equals 0 or x equals minus 3. If x equals 0, then y equals 2 times 0 is 0, plus 2 is 2. And if x equals minus 3, then 2 times minus 3 is minus 6 plus 2, which comes to minus 4. So your 2 points of intersection are 0, 2, or minus 3, minus 4. Okay, that was all right. Culpable. Okay, at a higher level, you may be asked to solve this or asked to prove that there is no point of intersection. So you've got y equals 2x plus 2x squared plus 3, and y equals x plus 2. So we're going to make it the same way. So we've got 2x squared plus 3 equals x plus 2. Make this side 0 because the x squared is on that side, so minus x minus 2. And we've got 2x squared minus x, and then 3 minus 2 is plus 1. Now if you try your AC method, so you'll have 2 times 1, which is 2. So you're looking for two numbers that add to give minus 1 and multiply to give positive 2. You know both numbers are negative, and there are no two numbers that multiply to give 2 and add to give negative 1. so it's not solvable. Okay, but the way to actually prove it is from the quadratic formula, you've got your b squared minus 4ac. Now, if b squared minus 4ac is less than 0, then it means they've got no roots. So even in a quadratic equation, if it doesn't have any roots, it means it doesn't cross the curve doesn't actually cut the x-axis. If b squared minus 4ac is 0, that means it's going to have one root. And if b squared minus 4ac is greater than 0, that it means it's going to have two roots. So for simultaneous equations, if b squared minus 4ac is less than 0, that means it doesn't have a point of intersection. And we can try it with these numbers. Okay, so your a is 2, your b is minus 1, and your c is 1. So b squared would be minus 1 squared, which is just 1 squared, which is 1. Okay, and then you've got minus, and I always put the 4ac in brackets, it just is easier to calculate. So you've got 4 times a times c, which works out to 1 minus 8, and which gives you minus 7. So you can see you can't actually square root a negative number, which means there are no points of intersection. And let's sketch this just so that I can show it to you, that if you sketch the two equations, they just don't meet. Okay, that's all for now. I hope after working through the examples you feel more confident about these simultaneous equations and will be able to tackle this kind of question in your exams and enjoy it. In my next video, Simultaneous Equations Part 3, I'll cover the circle and linear simultaneous equations. They're fun to do too. And remember, keep practicing. You're in control. Until next time, take care. Bye.